Hi, my name is Peter.
Hi, I'm Candace. Nice
Hi.
to meet you.
And you need help with calculus?
I do.
Okay,
I'm having
great.
like a real problem with this particular assignment. In particular, I'm having trouble with problem number 2, number 4, and 5. So.
Okay. Why don't we start just by refreshing our memory of what a derivative is?
Okay.
Okay. Remember a derivative? Remember in algebra class we talked about slopes of lines.
Right.
So if I'm going uphill,
Okay.
my slope is positive.
Right. Okay.
If I'm going downhill, my slope is negative.
Okay.
And then the steeper my line is, that's steep. This is really steep. So my slope goes up.
Okay.
Now the derivative is when we're doing something much more complicated than a line. So now I no longer have a line, but what if I have something like this? So it's not so easy. There I can say the slope of this line is going uphill, it's going uphill, it's going uphill. No matter where I am, it's always going uphill.
Right.
Here I'm going uphill, I'm going uphill, I'm going uphill, but now I'm going downhill.
Okay.
So the slope on a curve is constantly changing. And so that's what we're looking for when we're looking at functions. Instead of saying the slope is a constant 4. Here, the slope is constantly changing. Sometimes it's positive, sometimes it's negative.
Okay.
So that's what we're trying to find here. When we're trying to find the derivatives of these, we're trying to find how that slope is constantly changing and moving around.
Oh, that's
Makes sense?
interesting. Yes,
Yeah.
it makes sense. It makes sense. Totally.
Okay. So now when I have a function instead of a line, my slope is constantly changing, and so this is what this is going to tell us is how it's changing.
Oh, wow.
Okay.
Okay.
So we want to find the derivative of this function, 5 to the x cotangent of x.
Okay.
So do you remember how to find the derivative of a product?
I don't, to be honest.
Okay, that's fine.
Sorry.
Remember, your instructor probably told you the derivative of a product is the first function. You've got two functions here. This is the first function, this is the second function.
Okay.
You've got the derivative of a product of functions is the first function times the derivative of the second, plus the second times the derivative of the first function. So all we're going to do is just rewrite this. Our derivative is just going to be, again, the first times the derivative of the second,
Okay.
plus the second times the derivative of the first.
Okay.
So just rewriting them.
So it'd be like backwards or flipped? You mean like 5x?
First,
Yeah.
derivative of the second.
Okay. So then it would be,
Derivative of a cotangent.
yes, would be plus.
Derivative of cotangent is, I don't always remember either. Derivative of cotangent is minus cosecant squared. Is that right? Yeah. See, that's why we put these up here, so you can, if you're ever in here and you need help and you can't remember some of the formulas,
Okay.
look up here and there they are.
Awesome.
Sometimes our tutors don't remember. Sometimes I don't remember. Right?
Okay.
So derivative of this
I understand that.
is minus cosecant squared x.
Ah.
First derivative of the second
Okay.
plus the second, and I'm just going to rewrite derivative of the first.
Okay. All right.
What's the derivative of 5 to the x?
The derivative of 5 to the x.
Again, if you don't know, you can look.
A few
And
derivatives
your
of 5 to
your
the
instructor, when you're in class, he may ask you to have these memorized. He may not. So you need to find that out from him and just
Okay.
ask him, do I need to know what the derivative of this is? Do I have to have that memorized? Or are you going to give me, when I go in for my test, will you give me a sheet that has the derivative spelled out?
Right.
And I don't know, because I don't know your instructor, what he requires. But you need to know that before you go in for the test.
Okay.
So just go in next class, ask him if he wants you to memorize it.
Okay.
Then my suggestion to you, if he says to you, you have to have that memorized, my suggestion is you come in here again and write down some of these formulas
Okay.
that you see up here,
Okay.
because you'll be required to know them. And if he gives them to you, and if he puts a page on the test where he tells you, then don't worry about it. Just know where to look.
Okay, so it would be under the Math Resource Center, a few derivatives, is that right? Or it would be,
Derivative of a to the x. This is a would be 5, x is x.
okay. So it would be,
5 to the x ln 5.
Okay, so it would be minus, it'd be 5 to the x minus CSC squared x, right?
Mm-hmm.
Oh, okay, so, okay, I see.
There you go.
So that would be the derivative of that, would be that, and it's up there.
Mhm.
Okay. Oh, that makes it easier.
Sure.
That makes it a lot easier when you know the actual way to solve that. Okay then. So how do you do that? Like, is that the answer?
That's the answer.
Oh, cool.
You'd simplify if you can, but there's nothing you can simplify.
That's why it says
That's
do not simplify.
Oh, he even said do not
He
simplify.
does say
Great.
do not
Okay.
simplify, and I'm thinking in algebraic terms, so I'm always trying to find the
Okay.
what's it called, denominator or whatever.
But
So-
that's what he wants you to know. What I said. Some of those he might not ask you to memorize. He may give you those when you go in for the
Okay.
test. What he is not going to give you for sure is that first thing we talked about. You need to know the
Because
derivative
it
of
would
a
be
product.
5x over 1, like it would be in anything. So when I'm looking at that, it says d over dx in parentheses. Am I looking at the right one?
Yeah,
I
but
know.
that d over
The third
dx
one.
just means take the derivative. That just
The
means
derivative,
what
dx
that's
means
his
derivative.
directions. D over dx is just take the derivative.
Wow, I really need to know what these.
You need to know the derivative of a product is the derivative of the first times the derivative of the second
Yeah.
plus the second times the derivative of the first.
Yeah.
That I guarantee you he will not show you on a test. So that's what you're supposed to learn today.
Oh.
Derivative of a product is the first times the derivative of the second
dv is
plus
derivative.
the second times the derivative of
Yeah.
the first. And that's the
Yeah.
abbreviation for it.
Okay, cool. Then, if that's the answer to 2, what is 4?
Okay, let's look at 4. Well, 2 is a product. We've got
Two
two
is a product.
functions multiplied
Two
together.
functions.
This is a function. This is a function. They're multiplied.
1, 2, right.
Number 4 is a quotient. We've got a function
So the dividing.
divided by another function. And really, that's the two things your instructor wants you to learn for this lesson.
Okay.
Derivative of a product, two functions being put together by multiplication.
Okay.
Derivative of a quotient, two functions being put together through through division.
Okay.
Okay, so that was the first one was multiplication. Let's look at division. So, do you remember the way to find the derivative of a quotient? Do you remember the
Is
formula
it
for
up
that?
there?
And it's not up there because that I guarantee you he's going to want you to memorize. That he's not going to give you on a sheet of paper. So that one you have to know.
I don't remember.
It's the second, or we just call it the
I should
first
have
one. The first
studied.
one, yeah, the first one. It's okay. That's why you come here for tutoring,
I
because you don't remember
know.
things. The
I
first one will call
forgot.
you, the second one will call V.
Okay.
And that's standard. I'm sure that's what your instructor would
Yeah.
use as well.
Then-
So the derivative of a quotient is going to be the second times the derivative of the first
Okay.
minus the first times the derivative of the second divided by the second squared.
Okay.
And again,
So
you need to know that formula.
that would be the. Okay.
What
Because
I
it
would-
looks familiar. It's just when I'm not thinking about math, it just kind of.
And I'm just going to write what this is. It's the derivative of derivative. Why can't I write derivative? D dx of a quotient.
Okay, so
So
that is the
That's
answer.
quotient. This is the formula. Well, let's just call it u over v.
D over V.
Okay.
So D over dx derivative. Is that right? Is that
Derivative
dx derivative
of u
of
over
u
v.
over V? Okay. Wow. It's
What I would
surprisingly
suggest-
easy. than I thought.
It's knowing that formula. I want to suggest to you that you get a 3x5 card and write this on it and
Okay.
carry it around until you remember this.
Okay.
Because
I don't,
this is gonna
I
be-
came unprepared with the pencils, but I'm gonna use this pen actually.
Okay.
So I'm gonna write it. That way I can remember. This makes it more sense to me. So now, and then it equals D over dx. Like that's
Derivative
multiplying
dx.
clearly and by
U
u
over
over
v.
v. Okay.
Our first function, our numerator function will be u. Our denominator function will be v.
Okay.
Where in this problem, there's u and there's v.
Oh, okay. That makes way more sense now.
And now all we're going to do is plug into this formula.
Okay.
So v, our second function, again, it's u over v.
U over v.
This is u, this is v.
Right.
So our v is,
9x minus 5.
that's u, because that's the top one.
Oh,
We want
v.
the bottom
I
one.
apologize. So it'd be 2x to the second power plus 7.
Great.
So I inverted it.
So that's our v.
Okay, over.
Derivative of u.
Derivative of u is
This is a line.
a line.
So the derivative is just the slope.
Okay.
So the slope of it, if I gave you that line, would you know the slope?
I
No?
can say no.
Okay, you can say no.
No.
The derivative of is just y equals mx plus b. The slope is m.
Y equals mx plus b. Okay, so yes, now I remember recalling all of my algebra,
Okay,
which
so what's
is
the
stuck
slope?
in my head more.
mx, m. Slope is 9.
Mx. Okay, so it's 9. Right, mx.
Okay. So there's your
So
slope.
be 9.
Great.
So be 2 minus.
The bottom times the derivative of the top. The derivative of the top is just the slope
This is just the slope.
minus the
Minus.
top. So that whole
So it'd be
function,
the top, which is u.
9x plus 5.
9x plus 5. Okay, so that's where you would put that in. And then it would be,
The derivative of the bottom function.
so it would be 7.
The derivative is going to be the exponent times that coefficient of 2, so 2 times 2,
Is 4, clearly.
and then the x with
So
that
before x.
exponent lowered by 1, so 2 minus 1.
2 minus 1 is 1, so
Okay.
4x. Oh, okay, so like in algebra, like kind of like that seems algebraic
Yep.
to me. Over.
The bottom squared. So
Okay, so
2x
2x
squared plus 7.
plus 7.
Did I write that? Yeah,
Yeah,
squared.
Okay.
That's your derivative.
Oh, neat.
Now again, you could do more with this. We could multiply this 9 in and
Right.
play around and multiply this 4 in and
He says
distribute
do
all
not
this.
simplify,
But he
so
says do not,
don't.
so we're not
So
going to
this
do
is
it.
the-
But
that's
you
what I was
could.
thinking.
You could see
yeah,
if something
this one
would
you could, but this one
simplify,
you
but-
cannot. Or
Well, this is just the formula. This is just we're applying this to get this.
I'm sorry, I was thinking still back to the last problem. Okay, awesome. All right, well that makes a lot more sense and is a lot easier than I thought. Wow.
Yeah, you're just applying these formulas. But again, it is pretty straightforward. But you need to know these formulas. If you don't know these formulas, I mean, you don't even know where to start.
No,
So-
that's what I think made it so confusing. So, knowing
And that's what I was saying. What I do when my instructor is giving me a bunch of formulas to memorize, I just write them on 3x5 cards, like maybe the name of the formula in the front,
yeah.
and then the formula in the back.
Yeah.
And just, 3 times a day, I pull out those 3x5 cards and just go through them until I know them, so that anyone asks me, if you walked up to me on the street and said, what's the derivative of a quotient, I could go, oh, it's v du minus u dv over v squared. And I would know it like that.
Right?
But,
Yeah, I should do that.
but if you ask me the first time I see it, I won't know it. So again, just write it on a 3x5 card, keep
Okay,
it with you 3
yeah.
times a day. And I'm not
I'll
talking about,
transfer it.
okay.
Yeah.
I'm not talking about, again, 5 hours a day going through your note cards. Just 3 times a day, go through like 5 of them, and you'll know it before too long.
Oh, I thought this was going to be way harder. I feel like I totally understand algebra. Okay, so that's awesome. So if that's the answer, then 5.
Okay, let's do one more.
Thank you.
5 is going to be, we learned the product rule. We learned the quotient rule. 5 looks like the quotient rule. You've got a function on top, you've got a function on the bottom. But we can simplify that. What we want to do here is he's kind of trying to trick you to try to get you to use the quotient rule. But the quotient rule is pretty difficult. Let's not overthink this. Let's make it as easy as possible. And let's go back to our rules of exponents.
2x, 3x.
I'm just going to write it.
Okay.
And let's, instead of using the quotient rule, let's just simplify this. The square root of x can be written as x to the 1/2 power.
Okay.
Same thing.
Right.
So
right.
when I take the derivative of this, I'm just going to subtract exponents. 2 minus 1/2 would be 3/2. 1, just looking at the exponents, 1 minus 1/2 is just going to be 1/2. 0, because there's no exponent here. We can call x to the 0,
Is the
1.
one, yeah.
0 minus 1/2 is negative 1/2.
Oh, neat.
So what we've done is we've just transformed this into a different function. Instead of having to use the quotient rule now, I can just use my straight power rule,
Okay.
where the derivative, and you may not remember this, but when I
That's,
just have,
is that, what is that?
that means that's another way of writing derivative.
Oh.
Just put the prime there,
Wow.
and it's the same thing as writing the d over dx that we saw a minute ago.
Oh, okay. Dear.
Just lots of different ways to write the same thing.
Okay. It's important to understand.
The power rule says multiply the exponent times the coefficient and lower this by 1. And it's the easiest way to find a derivative. That's why I changed it from that, because that would be difficult. That's quotient rule, and boy, messing around with the v du minus the u dv over v squared, it's going to take me forever.
Right.
This I can do right now.
Okay.
Just straight the 3/2 times 3. 3 times 3 is
9.
9. Lower that by 1.
Okay, so that would be 3. Oh, okay. 3 times 3 in its place is 1. So it's okay.
1/2 times 8.
1/2 times 8 is
4. Lower by
I mean,
1.
I know that, but still.
Lower by 1.
Okay. So what
Negative 1/2. Negative times a negative.
is positive. So you mean plus. Yeah.
1/2 times 11. 11/2.
Okay.
And we're going to lower by 1.
Minus 3 over 2.
There's your derivative.
Oh.
And see how fast we did that rather than
That
having
was
to go through.
super fast. Wow, that was much faster.
So don't overthink these. If you can change it to a simple polynomial rather than two functions sitting on top of each other,
Yeah.
do the simple polynomial.
Yeah. Yeah. Sometimes I think the math is the easiest part to grasp, and sometimes learning the terminology and knowing what it is for me is the hardest part. So when you tell me what all this stuff means, it makes more sense to me. So then I know what to understand. Wow, that's amazing. Okay, awesome.
Derivatives are going to be important. It's going to be the whole first half of Calculus 1. So you just really need to learn your derivatives. It's something that's going to stay with you. It's just a really important concept in calculus. So we really want to learn. That's why he's giving you so many derivatives, because we really need to master this concept.
Okay, awesome. Well, that's amazing. Oh, that's awesome. Thank you so much for your help. I really appreciate it. It was very nice to meet you.
We're here
Thank
8 to
you.
7 Monday through Thursday, 8 to 5 on Fridays.
Oh, awesome.
But you can
'Cause
be
I'm
in
gonna
here all
need
day.
help.
Yeah, and we'll give you as much help as you need.
I need more help, I think. But that's amazing. So thank you so much for telling me that. And I'll definitely put those on some cards and get going on this. I really appreciate it. Thank you so much.
Well, thank you. Good luck in calculus.
Thank you.